What if your depression was never a mystery, just a misread signal? Your nervous system prints a code most clinicians never learned to scan. Computational psychiatry is building the dictionary, and the first word is the gap between your heartbeats. That gap is your heart rate variability. Researchers map that variation alongside brainwave patterns and sleep architecture to build dimensional models that track your mind in motion. Biomarkers are turning subjective suffering into physiology you can finally measure. The question is how precise this translation gets. Researchers writing in Nature Review's disease primers have found that computational models can forecast individual treatment responses before therapy begins by tracking prediction error signals, those dopaminergic teaching moments that update belief after reward or loss. People with blunted error updating show flattened autonomic responses that persist for weeks. Meanwhile, sleep architecture operates as a nightly ledger of synaptic homeostasis. A sleep medicine review's analysis found that when slow-wave sleep drops, dimensional mood scores destabilize within 2 days. Your genetic risk aggregates thousands of tiny variants into one probability curve, what clinicians call a polygenic risk score. Yet Nature Genetics data confirm that load only converts to symptom spikes when autonomic tone drops and sleep debt builds. Biology here is a dynamic equation written in real time. For years we assumed your mood painted your brainwaves. The electroencephalogram data say the opposite. Your resting alpha-theta ratio collapses first, and the emotional label arrives days later as a clumsy translation. Yet elite performers show parallel oscillatory swings under extreme load, only their dimensional scores stay flat. Something else decides whether neural instability becomes illness or resilience, a factor hidden in voltage and methylation patterns we have barely begun to decode, which means the next question is what your nervous system already decided to broadcast before you ever named the feeling. Your wearable registers a vagal withdrawal before you open your eyes. The algorithm maps that dip onto a prefrontal gamma collapse already in progress. That electrical signature pairs with a metabolic surge, a lactate spike from mitochondrial stress that standard blood work ignores. 3 days later, your dimensional score drops. Clinicians intervene at the end of that chain, the subjective report. The biomarker trail, however, starts with cellular energy failure. The next question is what happens when you interrupt the cascade at its metabolic origin instead of its emotional endpoint. Intervene at that metabolic origin, and prefrontal gamma steadies before dusk. Clinicians finally see the electrical weather clear. Yet the body keeps chemical scars on its DNA from last month's cortisol floods, CpG methylation marks that reset autonomic thresholds slowly. The brain feels rescued in hours. The methylome still breathes last month's stress for weeks. Human stress epigenome projects track this split timeline everywhere. Fast voltage, slow carbon. Which system actually governs the relapse? Because if tomorrow's vagal set point is being written by methylation while the electroencephalogram reads calm, we have been measuring recovery backward. The real fight is happening on a slower clock, and the next intervention targets memory written in chemistry, not electricity. Those methylation marks we treated as scars are being rewritten every hour by cytokines most clinicians never measure. Interleukin-6 and interferon gamma do not just inflame tissue. They recruit methyltransferases to specific gene promoters. The chemical memory is not stored in carbon bonds alone. It is actively curated by a neuroimmune system that thinks in weeks, not milliseconds. Your microglia are holding the pen, which means the next intervention has to speak the language of microglia and cytokines, a dialect endocrinology never learned. And that raises a blunt question. Why would evolution pay the metabolic cost of keeping a brain inflamed long after the threat is gone? Evolution pays that metabolic bill because a brain that expects danger outlives one that keeps getting surprised. That neuroimmune vigilance is a calibration error that once kept ancestors alive. Computational psychiatry finally gives us the language to update it. Track your slow-wave sleep against your morning heart rate variability. When the gap between them widens, you have roughly 48 hours before dimensional scores shift. Intervene at that lag before the symptom ever forms. The full research archive, all figures and methods, lives at jmthomasofficial.com. That 48-hour lag is your new diagnostic baseline. Most clinics still wait for the collapse. You can read the precursor now. Slow-wave sleep, morning heart rate variability, and neuroimmune markers stream into one-dimensional map. Your biology becomes a signal you track, not a story you tell. Start tonight. Log your sleep depth against your waking pulse variation. Watch for the divergence. When sleep drops and HRV flattens, move within 2 days. Cold, breath, light, or carbohydrate timing. The intervention matters less than the timing, and the timing is now yours to own. The full research archive, all figures, methods, and references is waiting at jmthomasofficial.com.